Hello, our most developed student. My name is Confident and welcome to Equivalent Text 24-minute lesson. The lesson today is factorization and completing a square. Some solutions of the past exam papers. Now, the first one that we're going to look at is the following question. And you are required to factorize completely. Now, if you can check on this particular question, you can see that y squared plus 1, y squared plus 1, y squared plus 1 is repeating throughout. So we can take that as a common factor. Take it outside. Now what you're going to remain with inside is this and that, which is 10x squared minus 23x plus 12. Now, we have then to factorize this. And when you're factorizing that, just to do what? Remember, the sum we are looking for a number in which the product is this number times that number, which is 120 squared x squared, and the sum is minus 23x, and the factors is equal to minus 15x and minus 8x. If you multiply 15 times 8, you get 120. If you add minus 15 minus 8, you get minus 23. So what I'll have is 10x squared. Instead of 23, I'm going to write minus 15x minus 8x plus 12. Looking at the first two, what is common in the first two and the last two? You can see that in this one, 5x is common there. You are left with 2x minus 3. And the next one, what is common, is negative 4, which is 2x minus 3. Then you've got 2x minus 3. We are writing either any of these that are in the brackets, and then you write what is outside the brackets, which is 5x minus 4. Then that becomes the final answer. Then if you're marking yourself, this is the answer for that. Let's look on at another question. Looking at this question, you're supposed to factorize completely. Now, looking at it, you can recognize that there is something common between 27a cubed and 9a squared. And 27 and 9 is common, a cubed and a squared is common. So now if I can factorize those, I will have 1 plus 3a minus, because negative is common outside, I put a bracket. What I'll get there, just before that, minus what is common there is 27 and 9 is 9. A cubed and a squared is a squared. Now put a bracket. And then here 9 into 27 is 3. A squared into a cubed is a. Negative is already outside. This becomes a positive. 9 squared, 9a squared, 9a squared, it becomes a 1. Now remember, for you to check that you're correct, you must ensure that when you multiply this and that, you get back to the previous answer, which is correct in this case. Now, if we move on, we can rearrange that. We can rearrange this because 1 plus 3a is the same as 3a plus 1. So 1 plus 3a minus 9a squared is 1 plus 3a. I'm just rearranging so that it is the same. Now you can see that this and this is common. You can factorize it out. In a way, this is like you have got a bracket here. And then when you've got a bracket there, what is outside is a 1. So if you can take out 1 plus 3a outside, what you're going to left in the first case here is going to be a 1. You're going to have a 1 in the first one. In the second one of this one, you're going to have a minus 9a squared. Now if you continue, you have got 1 plus 3a. Now this one, that is the second, is a difference of 2 squares if you can recognize it, because this is like 1 squared minus 9 is same as 3 squared a squared, which is equal to 1 plus 3a, which is, remember the difference of 2 squares, you take the first one, which is 1 minus 3a, and 1 plus 3a. So now the final answer, because 1 plus 3a is repeating twice, you will have 1 plus 3a squared 1 minus 3a. Again, remember this is a difference of 2 squares. Now let's look at the next example. We are to factorize this expression. So you can see the first thing that we have to identify is, let's look at what is common between the numbers, and it's 6. And what is the other common between the variables? It is this is x. So 6x there is common. 6 into 24, it's 4. X into x is 1, so 4 is common. Minus 6 into 24, it's 9. X into x is common, so you are left with that. Now with that, you've got 6x. This will give you a difference of 2 squares. Why am I saying that? Look at it. 4 is 2 squared minus 9 is 3 squared, and then y to the power 16 is 4 squared. So everything can be put in squares. This then can continue to give you 6x. Now you write the first one, which is 2 minus 3y4, and then you've got 2 plus 3y4. Now remember, you can always check as a proof that if you multiply these, you're going to get back to the previous. Okay, That is a way of verifying that you're in the right track. Now, if we continue, what we have, which is equal to, at this point, I think it is complete. That is the answer that you get. So, the final answer here, because we can't further factorize 2 minus 3y4 and 2 plus 3y4, that is the final answer. Let's look at the next example. Where to factorize. This is to factorize. Now, if we're to look at the first one, looking at the top, you can see now the only thing you need to focus on are the powers there. This is x to the power 4 and this is x to the power 3. So you can take out x to the power 3 because you are taking out the lowest power, that is the factor. What you will remain with, 3 there, now 1 will remain, you write x minus 1. All over, you look again at the bottom, you will have x to the power 3 also is common, but in this case now you'll have x plus 1. Now already you can see that the cubed and the cubed will cancel later. You come back now to this one, which is here on top. What is common here? You can see x plus 1 is common. You can take out as a factor. So what you'll have is 1 plus x as outside. Now 1 plus x into 1 plus x, you remain with 1. 1 plus x into minus 2x, 1 plus x, you remain with negative 2x. Where did I get the 1? Remember, it's like there is a 1 outside here. Okay, now divide that by x minus 1. Now you can start cancelling. You can see now, remember cancelling, you can cancel that and cancel that. You can cancel x plus 1 because there is a multiplication sign here. You can cancel that x plus 1. You can only do if it's multiplication. You cannot do if it's a positive sign or a negative sign. And then also this one will cancel out. Then what is remaining here, if I'm correct, it's 1 minus 2x. Then that's the answer. Let's look at another example. Let's look at this given question. Now again, what you need to do is to solve this type of equation one step at a time. Let's start by looking at the top there. You can see that x is common there. Why? Because x squared minus 2x, you can see it is the x that is common. And you go again to the denominator, you can see that there is x squared, this is a power 1, so we take this smallest power, x is also common. Now if you factorize this fraction, you will have, I said, x there, you have got x minus 2 all over x again, x plus 1. Remember, I can always open the brackets to check if it takes you back again to the top answer. And then multiplied by, we come again to the second part here. You can see again x is common because there is a power 1 there, the smallest power of x, which is x and x there. X is common. And then at the bottom, we need to factorize. And when we are factorizing the bottom, remember, the product is this and that, which is minus 2x squared, and the sum is equal to positive x, 1x, and the factors are, so we are looking for a number which when you multiply you get minus 2x squared, when you add you get positive 1x squared. And from here the two factors are positive 2x and minus 1x. Now I'm going to factorize it outside so that I don't mess up on my working there. So I will have 2x squared. Instead of having positive x, this positive x, I'm going to write now the factor that I got, which is plus 2x minus 1x negative 1. I factorize the 2 because looking at it, what is common there is 2x, and then what will I have is x plus 1. I take out again here negative 1 there because it's common, minus 1. I must get x plus 1. All the time, what is in the brackets must always match. So it's x plus 1, 2x minus 1. That's what I'm going to put there. So this is times, remember x was common there, which is x squared minus 1 all over the answer that I got down, which is x plus 1 and 2x minus 1. If we continue, we have got x minus 2 over x plus 1 times x. Now recognize that this is a difference of two squares. So when you solve it, remember it's x minus 1, it's x plus 1 all over x plus 1 to x minus 1. As I say, this is a difference of two squares. After that, we can cancel now because there is a multiplication sign. X plus 1 cancels with x plus 1, and then x will cancel with x. If I can use this, x cancel with x, I said x plus 1, x plus 1. And what else is remaining? Therefore, what you are left with is x minus 1 all over x plus 1 2x minus 1. Then this becomes your answer. Let us look at another example again. Now let us look at this kind of a problem that we're given. When you're given such a problem, the best thing is to first factorize each and everything, and then you write your final answer once. For example, I can do it like this. I can now start by looking at the factors of each and every thing that I'm given. First one is x squared minus x minus 6. If I factorize it in our way, remember the product sum, I'll have here x minus 3 and x minus 2. If you x plus 2, sorry. If you expand this, you will discover that you get the previous one. How about x squared plus x minus 20? If you factorize this one again, you will have, because we've got negative 20, we need two numbers. When you multiply, you get minus 20. When you add, you get plus 1. So the negative one is 5 and 4. But now 5 must be positive because it's positive x plus 5, and then x minus 4. If you multiply this, you'll get that. Now how about x squared minus 25? This is a difference of two squares. It's x minus 5 and it's x plus 5. And then how about 2x minus 6? This one, 2 is common. You will have x minus 3 coming in. How about x squared minus 3x minus 10? This one again, you are looking at a number. The two numbers, when you multiply them, you'll get negative 10, and you add them, you get minus 3x. And the two factors there is 5 and 2. But look at this, because we've got a negative 3x, for 5 and 2, negative 5, the bigger number must be positive, must be negative, and then x plus 2. Now the positive number must be the smaller number. And then if we can do that, because we have now simplified everything into factors, you can now write everything simplified. How does it become? So this is what you're going to have, but now we cannot start cancelling because of that division sign. We must change it into a multiplication sign. What do? You invert the fraction and it becomes this. And then with that we can start cancelling, and starting to cancel, you can see x plus 5, x plus 5, x minus 3 goes, and then x minus 5 goes, x plus 2 goes, x minus 4 it goes, and the answer then it becomes 1 over 2. That's the answer. Now let us look at a point of given addition and subtraction. Now if you are given this kind of a problem, you need to first identify your denominators, because you need to find the common denominator. Now there is something that I want to show you that is a trick here. Now remember, m squared minus n squared is equal to m minus n, m plus n. Now this can be the common denominator, but unfortunately we have got n minus n, n minus, not m, n minus m on the other side. So which means n minus m, it becomes minus m minus n. Do you see what I just did? So that I can match it to the denominator. If I expand this further, it's minus m plus n, which is equal to n minus m, which goes back to that. But the one that we need is to match that. So when you write it final, it becomes like this. So they wanted to trick you now with these two signs, the positive sign and the negative sign. So what you need to always know is that when the other one is interchanged, this positive sign will be affected by this negative sign. So everything will become negative now, which becomes, so now you see that this particular positive sign has been affected by this negative. Why? Because the negative has managed to make it m minus n, not n minus m. Let's continue. Now the common denominator, then you can see that this is appearing even here. So it's m minus n, m plus n. So we have got m minus n, m plus n as the common denominator. This one, m minus n into that, it's a 1. 1 times 2 minus m minus n into m minus n, m plus n. We have got times that, it's 1. What is remaining here? Because this one and that one is a 1, so you are left with m plus n. Therefore this becomes, when you simplify, 2, you can open the bracket, minus m minus n over m minus n, and then m plus n. Then this kind of like becomes your final answer. Now, as I said, to remind you what happened, if you are given m minus n and you want to change it to become n minus m, this is what you do. If you want to change it to become this, so m minus n is equal to, you take out the negative, it will become minus m plus n, which becomes negative. You rearrange because you always start with the positive, n minus m. So you see, by taking out a negative, you rearrange. Where there was n, it becomes m. Where there was m, it becomes n. So this is m minus n. So this is what the negative does. Now we've come to the end of our lesson. Let us continue now looking at the past exam questions again on the addition and subtraction of fractions, as well as looking at the factor theorem. Thank you.